Hi, I'm Colin Walls, and I'm here once again to talk about embedded software. Today I want to talk about the use of a memory management unit, an MMU. Now, not all microprocessors have MMUs available, but nowadays many do. And it's interesting to look at the functionality that these devices provide. Broadly speaking, what an MMU does is it will take an address, a logical address, so that is an address used by the software, and translate that into a physical address. Now, without an MMU, physical and logical addresses are the same thing, but the MMU allows the mapping to be changed. Now, why would you do this? Well, broadly speaking, it gives the opportunity to produce more secure software. So if we start out with a microprocessor with no MMU, and say we're using a real-time operating system, it's likely to be a multi-threading operating system. The way this is mapped into memory is very straightforward. Typically the RTOS itself will be at the base of memory, and all the threads code will follow up through memory. That's fine. That's the way we've been used to working with processors for many years. The drawback is that each task, each thread, can access all of the memory and can access the memory of other threads and potentially cause damage. That's not something we really want to happen, but we're vulnerable to that, and obviously we write our code carefully to avoid that possibility. There is another option, and the option is to use an MMU to remap memory, and we then have an operating system which works on what we call process model. Now, with process model, the real-time operating system itself is mapped to the base of memory, as is each of the tasks, which we now call processes. So each of them thinks it has the whole of memory to itself, starting from a baseline of 0. This means that each task's memory is completely protected from the others, and so is the operating system. Its memory is also protected from the tasks. So this is very secure. The downside is that every time we change context, the MMU has to be reprogrammed as well as the context reloaded into the processor. That's an overhead we have to pay, and this is typical of operating systems like Linux and so forth. There is an interesting middle ground though. The MMU has another trick, and that is, instead of remapping memory, it can simply adjust the visibility of memory. So in other words, make areas of memory disappear. So we can arrange that each time a thread is active, the only memory that's visible to that thread is its own memory and the necessary parts of the operating system to let it function. If it tries to access memory which is outside of that space, a trap will occur and no damage will have happened to that memory. This is called thread protected mode or lightweight process mode, and this is available with a number of real-time operating systems today, including Mentor Embedded's Nucleus. So that's a quick introduction of what MMUs are all about. They're quite complex devices. Typically, as a programmer, you do not need to know how they operate. The operating system will do it for you, but understanding broadly what they're doing for you is quite beneficial. The key thing is they're not always available, so don't assume one's there. If there is one, look into the options that your operating system provides. That's all for today. I hope you found that useful, and I'll be back here again soon to talk about some other aspect of embedded software. So, bye for now.